Okay, now we go to talk about the file input output. And first we start from the definition. So, file input output is the saving program data permanently so that it can be reused and not lost after the program is closed. So the C language provides a special structure called file to manage interactions with files, and this structure is also called a file handle, and it is declared in the stdio.h header. So how to use file pointer declaration is the file pointer fp, and the fp is some variable. Fp is a pointer that points to the file structure. Just like opening a file in the general has 3 steps, when we create a program using a file handle, there are also 3 steps: is the opening file, processing file, and closing file. So we using the fopen function to open a file, and this is the general syntax. That is, file pointer is for pointer to a file structure. Fopen is used to open a file. File name is the name of the file to be opened, and mode is the type of the operation. This is a general format. File pointer fp, fp equals fopen, file name, and the mode. This is the mode that we use in file handling, and this is a mode for the txt file. So the file have 2 types: is the binary and txt. This is the mode for the txt file, that R is for read only, and it fails if the file doesn't access. R plus is read and write, and it also fails if the file doesn't access. And the W is the write only mode, so that can be create a new file if doesn't access, and delete the old contents if it does. The W plus is write and read, like W, but can also read. A is append, that is for append at the end of the file and create a new one if it doesn't access. And A plus is append and read, that is can read and append at the end of the file. When we use a binary file, we can add B after the mode, like RB, WB, and AB, that is for binary file. This is the example for the open file. We use file pointer fp, and fp equals fopen, and ex.txt is the example of the file name, and we use W for the mode in write mode, and we write the data, use fprintf.
Hello everyone, my name is Muhammad Fathur Rahman Yasin. My code assistant is TIR, and now I will explain about processing files. So data processing in files can be done in 2 ways: as a text files and as a binary files. Text files are suitable for storing simple data such as string or text. Why? Because the content is written in human readable form, so it will be easier for us to see the content of the files. Meanwhile, binary files are more suitable for storing complex data such as struct, because when we dealing with a complex data such as struct, using text file is less efficient, since we must save or write each element of the struct one by one. In contrast, binary files allow us to store entire struct directly in a single operation, making the process faster and more efficient. That is why binary files are usually recommended for handling complex data. Okay, right now we move to the text file. First of all, the definition of the text file. So the text files are files that store data in character form so that they are easy for human to read. As I said before, that the content on the text files is written in a human readable form, so it will be easier for us to see the content of the files. And text files are usually used to process a simple data. Why? Because as I explained before, that text files cannot store the complex data such as struct. It has to store it one by one, so it's not really efficient to use a text file for a complex data. Okay, let's move to the writing and reading on a text file. To write and read on a text file, we use two different functions. The first one is to write string data to a file. We use the fprintf function. This function allows us to send or write formatted text into a file. And as we can see in the general form of fprintf, it says that integer fprintf. What is integer? So integer is the return value of the fprintf function. So fprintf function will return an integer that tell us how many characters were successfully written. Okay, let's move to the fprintf parameter. The first parameter is file restrict stream. The file restrict stream will be filled with the file pointer's name. Okay, and the second one is the const char restrict format. What is it? It will fill with the output, like the content, what content we want to write into the file. Okay, the next one is to read string data from a file. To read string data from a file, we use the fgets function. Unlike fprintf, this function returns a char value, which contains the text that was read from the file. As we can see in the general form of fgets, it says that fgets return the char value. Okay, as we can see in the description of fgets reads a single line of text from a file into a string, returns null on failure or end of file. So if it fails to read, it will return null. Same like when it reaches the end of the file, the fgets will return null. Okay, the conclusion is fprintf is suitable for writing, while fgets is suitable for reading string data. Okay, now there's some addition. In addition to using fgets function, fgetcheck can also be used to read the string data. The difference of fgets and fgetc is that fgets is used to read the strings, while fgetc is used to read a character. So fgets is read one string, while fgetc is just read one character of the string. Okay, now we move to the adding data to a text file. The method for adding data to a file is almost the same as the method for writing data. The difference lies in the file mode argument in the fopen function that is currently opening the file. Simply, you can just change the mode W or W plus to A or A plus. It's to append. Okay, now we move to the coding example. Okay, here's some simple code to write data to a text file. As we can see in the first line, it says include stdio.h. It's to include the stdio.h library into the code. What is stdio? Stdio is the standard input-output libraries. and the next line is in main. It's the main function. The next line is char name 20. What is it? It's to declare the name variable with a char data type, and it has 20 characters. Okay, move to the next line is printf, enter your name. This printf function is used to print the enter your name into the terminal. And the next line is gets name. So we want to take the input from a user and put it into the name character and name variable. Okay, here is the file handling side. The first one is we have to declare the file pointer, which I name is with f_tags. You can name it with anything you want, but I name it with f_tags. And after we declare it, we should open the file first. As you can see, guys, in the first parameter, it is the name of the file. We use .txt as a name or identity of the text file. As we can see, in the second parameter is W. What is W? W is the mode to write text into the file. So the next line is fprintf. Now fprintf, as I already explained before, that fprintf is used to write the string to a file. As we can see in the first parameter, this is the pointer file's name, and in the second parameter and the third is contents what we are gonna store into the file. So it says that %s it's linked to the name variables. So the name variables will be the contents of the name variables will be stored into the ftext files. And after we're processing the data, the file, after we write it or maybe we read it, we should close the file using the fclose function. And the last line is the return 0. It's this represents that the function successfully execute. Okay, let's run this code. As you can see, it needs our input, so we will input Daskom laboratory, and then it ends. So we can see in the user file that fills with what we already write before. The Daskom laboratory will fill into the user.txt file. So this simple code is working, guys. Now we move to the adding or appending data to a text file. Actually, appending data to a text file is similar to writing the data to a text file. The difference is on the mode argument. When we're going to write a data to a text file, we're using the W mode. Is to write data. However, when we are going to append the data, we're gonna use A mode. It's to append, like that. So when we execute this code, it will enter our name. We will input the looping forever. Okay, as we can see in the user.txt, it's append and the looping forever in the data. Okay, now we're moved to the fgets example. So this simple code is to read the data from a file. So the first line is to include the standard library, and the next line is the main function, and the next line is to declare the variable name it used to store the data that we're gonna read from the file, and we put it into these variables. So we move to the file handling. So first of all, we have to declare the file pointer, and after that we should open it with the same name of the file. And the second one is the mode. When we write, we use the W. When we append, we use the A. And to read the file, we use the R mode. Okay. And the next line is we're using the loop, the while loop. And the while loop contains the condition of the while loop. And the condition of the while loop, we fill it with the fgets and not equals to 0. Well, why not equals to 0? Because when fgets reach the end of the file, it will return the 0 or the null. So while it's not 0, it will read all of the content of the file. Okay, so when we reach the end of file, the condition will not fulfilled. So the loop will stop, and we'll move to the return 0, the end of the file. Okay, let's try to execute this code. So the output will be Daskom, laboratory, and looping forever. It's similar to the content of the file on the user.txt. Okay, now we'll move to the last example. This is the example of reading the data, same as before, but the difference is on the while condition. We're using the fgetC. Before we're using that fgets function, but right now we're trying to use the fgetC function. So the code actually similar as a fgets function code, but the difference just in the while condition. We use this. So when we're read one character in the text file, we put it into the name variables, and after that we're printed while the fget is reading the file, not on the not reach end of the file. It will not return the null, right? So A of f is similar to null or 0, because it's return the null value. So while it's not or it's not equal to null, the looping will be executed. So when it reaches the end of the file, or it returns the null value, the looping will be stopped, and it come to the next line, and it's to close the file, fclose f_text. And the last one is a return 0. It's the end of the coding. Okay, let's try to execute it. So the output will be same as before, but the difference is how the program execute this file. So when we're using the fgets, the file will read the data with a one string, while However, when we are using the fgetc, the file will be read per character. So as we can see in the user.txt file, it's similar to the output of the program. So yeah, this code is working. So the next one will be explained by Shafiq.
My name is Safik Asbidinata, and my assistant code is S, H, and D. Now, I will explain to you about binary file. First of all, I'm gonna explain the definition of it. What is binary file? A binary file is a file that stores data in the form of bytes, similar to RAM, and is usually used to store complex data such as structure. There are two functions for writing and reading data in the form of memory blocks consisting of bytes. For example, they can be used to write any data type such as float or struct. These two functions are called fread and fwrite. These are the general form of fread, and this is the general form of fwrite. There's a description of it. The PTR is a pointer that points to a temporary memory as a buffer for reading or writing a file. There's a size, which means the size of a block of memory in bytes to be read or written. There's also nmem, or number of memory, the number of memory block that will be read or written at one time. There's a stream, which means a file pointer that points to a file. There's also a size underscore t, which means a special integer type that stores the size of object in bytes, typically returned by the size of operator. Both functions return the number of memory block processed, and to handle multiple blocks, or nmem, an array must be used as temporary storage for the PTR argument. The method of adding data to a binary file is almost as the same as for writing data. The difference is you use A instead of W. A stands for appending. And now let's go to the demonstration of writing, reading, and adding data to a binary file. Okay, now we're gonna learn how to write, read, and append in binary file. First, we have to initialize the file data type. And from line 6 to 9, there's a struct which contains name, student ID, and grade. Okay, first of all, we are going to open the file using a function fopen and naming the file student underscore data dot. We use the WB as a mode, which means writing binary. After we input the college student data, we are gonna write the data to the file using fwrite function. We are gonna writing the struct, which called data, and the size of data. There's one here. One is we are gonna writing the data from this struct one time, and fbinary is the variable of this file. We are gonna close the file. Okay, I'm inputting two college student. The name is John. The student ID is 01 with the grade 89, and we're gonna put Lisa, student ID 502 with a grade of 90. Okay, now the writing is done. We're going to continue to the reading part. Same as the writing part, we are gonna initialize the file and the struct, and we're gonna open the file the same as the writing. The difference is we use RB right here for reading binary, and the function is while fread. This is usually the same as the fwrite. This is the address of this struct, and this too, the address of this struct. The one right here is we are going to read it once, or one block. This is the file name, and if the fread successfully read, it's gonna keep going to display the name, the student ID, and the grade. Don't forget to close the file, of course. We're gonna check if John and Lisa is there. There's a John and Lisa. Next, we're gonna append the data to a binary file. It's the same as the last two, which mean initialize the file and the struct. The difference is we're gonna open it, the file name student-data.dat with mode A, B, or append binary. We're gonna enter how many students we want to append and fill the student identification right here, and we are going to write it using function fwrite as the same as the writing part, which means this is the address of the data, the struct, and this is the size of struct also, which the struct name data. One is for, we're gonna writing it for one block, and there's a f_binary for this variable right here. Don't forget to close the file. We're gonna append a student. I'm gonna append the tree maybe with the name is Sarah. The 503 with a grade of 78, and there's Karen. With a grade of 6, and there's Caleb. And the grade is 90. Okay, now we're gonna check if the append is in the file using the reading function. Okay, now there's a 5 student down here. There's John, there's Lisa, there's Sarah, Karen, and Caleb. That's all from me. Thank you, everybody.
Okay, so now I will explain random access to binary file. Okay, in C we can access files randomly, random access, meaning we don't have to read from the beginning of the file separately. We can jump directly to a specific position in the file using fseek. Okay, this is a general form fseek. Integer fseek file stream along integer offset integer whence. Okay, so the description from for this syntax is offset. Offset is meaning a distance in bytes to be shifted. If the offset is positive, they will go forward. If negative, they will go backward. Okay. For the whence is a reference point. So is 6_set is meaning from the beginning of the file. If 6_car currently, that is from the current position. Okay, if 6_n meaning from the end of the file. Okay, so now we go delete data in binary files. Okay, in delete data in binary files, we have a remove syntax, remove file, and rename file. Okay, for the procedure, we have one, the problem with deleting data. in binary files, we cannot directly delete data in the middle of the file. Solution of this problem: create a new file that contains all the data except the data you want to delete. So, procedure for deleting data: open the main file in the read mode, write binary, and go create a backup file in write mode, write binary. Copy all data from the main file to the backup file, except for the data to be deleted. Nah, after that, close both files and go delete the main file using the remove function. Okay, last, rename the backup file to match the name of the main file. Use rename. Okay. This is for remove file name, and this is for rename. Rename old name and the new name. Okay, next one, we go to update data in binary file. Okay, data update procedure in binary files. Okay, of the first one, open the main file, original file in the read mode, write binary. And the second one, create a backup file, temporary in write mode, write binary. And 3, scan each record. Okay, use a while loop afraid to read records one by one. To find the data to update, use string compare if the search is based on a string. If the record match, perform the update operation on a specific file. Change the value, add the balance, update the XM score. Okay. Next, write the update data to the backup file. If it match, write the modified record. If it does not match, write the original record unchanged. 5, close both file. And the next, delete the main file using remove file name.dat. Okay, for the last, rename the backup file to the main file name using rename temporary.dat file name.dat. Okay, so that's it for me. Okay, now I will explain random access file binary. Okay, for the first one, we have include studio.h as a library, standard library. Okay, the next we have a main function file pointer file fp integer data. Okay, so we have integer data that's array that's contains 7, 8, 9, 10, 8. And the next we have fp fopen. We create the file that's using write binary. The name of the file we create is data.bind. Okay, for the next, fwrite data, size of integer. Okay, we input this data contents to the file here. So this is data that's contained here, and size of integer because this is integer, and 5 because he have 5 data, and we go direction to here. So data.bind have contain this number. Okay, the next we must fclose. Okay, the next fopen data.bind. Okay, this is we read binary, or we read the file we create. Okay, for the next ifseek. So I want to use this code to display the number 9, and this code actually works if there is a lot of data in the file. Here we want to display number 9, which is located at the third position. So let me explain here. First, let me explain 6_set part. 6_set means the starting point from the beginning of the file, from here, from 7, right? Why did I write 2? Okay, because we want to go 9. So if we go from 7 to 9, that means we jump twice. Why positive? Because I want to go to number 9. That is before the number 7 or after it, like that. So we can get the third data output, which is 9. Okay, so the explain of the code. That is, let's go, we run the code. Yes, they will display number 9 because the third data is 9. Okay, so now I will explain the function of rewind. So we know we have the rewind function. Okay, so we have a library as usual in studio.h. Then there we have the main function. This is main function. And here we have data containing 7, 8, 9, 10, 8. Next we create file name. We create a file name data.bind. Then we write the data we create. Okay, into the file we create here. Here we point off to the data.bind. For the content of the data, content is here. After that, don't forget to fclose. After that, we open the file in the read mode write binary and use fread to read it. We read the file once. If we read it, for example, the data that comes out is 1, which is the number 7. Usually, if we want to read the number 7 again, we cannot because it's already been read. So the rewind function is used to read it again, allowing it to read the number 7 again. So the first data is the number 7 again. That's how to the rewind function. So this is the rewind syntax. Okay. We will run the code. Let's here. First data is 7. First data again is 7 again. So that's all for me. And now I will explain how to delete data in a binary file. Here there is a library as usual. Then there is a main function. The next we create another array containing 7, 8, 9, 10, 8. And then we create the variables name, x, and target. Next, we open the file and create file name data.bind and use write binary to write data into the file. The next, we use fwrite to write data into the data.bind. So next we use fwrite data into the data.bind file. After that, we close the file data, the file. After that, we close the file here. We set a case where, for example, if we want to delete the number 9, we simply input it a number 9, and the target becomes the number 9. Here we use the write binary and use to write binary to write here. We open this file to read and we create this file to write. Okay, after that we store the data in the variable x, while data in the variable x, then we read it once. Here we go point to the file here, point to here. So the next, if this equals 1 is true, it's enter the target. If it's not equal to 1, is it an error or exit the loop. Here, if x is not equal to the target we want, it will be written to the temp file. So the target we want or the number we want will not be written to the temp file. Okay. If we input the target 9, here they will not write the number 9, just only 7, 8, 10, and 8. Okay. The next, we close about file. Then we remove the main file or the data.bind and we rename the temporary bind to the data.bind. Temp bind to data.bind. We rename. Okay. After that, we will output data. Print data. Data successful delete, if any. Okay. Let's run this code. Wait. Okay, we will run this code. Enter the number you want to delete. For example, 9. Okay, data 9 successfully delete. Okay, it will be 9 will be delayed for the data. So this is how actually works to delete data file in binary C. So that's all for me. So now next I will explain how to update data in binary files in C. So we have a library as usual, include studio.h. Then there is a main function file. Here we create an array containing the values 7, 8, 9, 10, 8. And then we create a variables name, position, and the new value. Then we create a file name data.bin using write binary. We will fill this file with the data we create earlier, which is 7, 8, 9, 10, 8. So we input the data. And direction to this file. And then we close the data using fclose. After that, let's say we want to change the position. For example, position 1. Initially, position 1 was 7, but let's change it to 6. So we enter the number 6 into the new value. Next, we use the R plus B write binary mode to read and write. Then we use F6 and FP Y position 1. Why position mean 1 here? Because in C programming language, the data we create or the array containing 7, 8, 9, 10, 8 actually is not 1 to 5, but 0 to 4 because it starts from 0. So here we set the position to mean 1 to move back 1 position to align with the that we want to update. The position to mean 1 to move back 1 position to align with what we want to update. The seek_set function is used because we want to start from the beginning of the file. Next, we use fwrite here to insert the new value into the file, so it will be replaced and update from the original number 7 to the number we want, which is 6. Now we will try to run it, and it works as expected. Let's go. Okay, position 1 we change to 6. Okay, the data should is changed to 6. Okay, that's all from me.
This is the last steps for file handle is closing a file, and the general form of closing a file is fclose. This is a syntax int fclose file pointer string. Function is for closes the open file, and if successful, the data buffer is written. Then the file is closed. If failed, returns EOF. The return value is 0. That's success. EOF is error. Okay, and we have some additional notes. This is for clearing a buffer. We use flush. This is the general syntax int flush file pointer stream. Stream is a pointer to file. This function is used to clear the buffer contents and write them directly to the file. We can see the example in here. So this is the example for the flush. First we write with printf, write the first line, and it stored in the buffer first, not immediately in the file, and we force the buffer contents to be written to the file immediately with flush, and write the second line, and the second line is goes into the buffer again. Will actually be written when fclose is called. So the first line and second line is different. First line we goes to the file is with flush, and the second line is with fclose. So the next additional note is about writing and saving file position. We use fget post and fset post. So the simple analogy is fget post for placing a bookmark, fset post is returning to the bookmark. So we save the current position with fget post. This is the general syntax. Int fget post file pointer stream fpost_t pointer post. The position value is stored in a variable of type fpost_t. And we return to the previously saved position, use fset post. The general syntax is int fset post file pointer stream const fpost_t pointer post. This function will return processing a file and needing to go back to an earlier part. You can see the example in here. Okay, so we write the first line is hello world, and we save the current position with fget post at the end of the first line. And we write again in the second line is fprintf. This is the second line, and we use fset post, and we add the new text for that position is edited text. And this is example.txt. This is so the edited text is overwritten for the second line. So after hello world is edited text, not this is the second line. Okay,